Hey, we're finding the area under the curve. So we're going to want to find the area of both of these shaded regions here, and we're looking between -2 and 2. And so this looks like a picture that's symmetric about the origin here. In other words, if we take it and rotate it, we get back the same picture. So this is how we're going to do it. But first, let's talk about this. So the curve, or the straight line in this case, is defined as f of x is equal to f, or x. And if we integrated between -2 and 2 of x of dx, remember that's how we're going to find the area under the curve, but if we did it this way, look what happens. We end up getting 0 as our final answer. Now, we can't have 0 area. How could this possibly be? I mean, look at this picture. I mean, something's going on here if we've got 0 area. I mean, I've clearly got these two shaded regions right here. Well, it turns out that, like in the previous problem, if we were finding the area up underneath the x-axis and the curve, we end up getting a negative number. And then so we would take this number, which is negative, add it to this number, and our net would be 0. Well, that kind of tells you something about the picture here, and that is that this area must be equal to this area here, which I'm labeling as A1 and A2. And so that's the reason why we're getting 0. So if we've got a picture and it looks like it's got some symmetry to it, you can do something to save a whole lot of time, and that would be just integrate between 0 and 2. Get that number and then multiply it by 2 and you're done. That usually works every time. But we're going to go the long route on this and kind of demonstrate what's going on. So I'm going to find the triangle that's below the x-axis on the left, and so we're going to integrate between -2 and 0 of our function, which is defined as x, and so we do. And we set it up, and then we do the calculations here, and yes, we get a negative number, and it happens to be -2. But since area can't be negative, we just make it positive. So the area, and I believe labeled it as area 1, is 2 square units. Now we want to find the area between 0 and 2, and so we do that. Take the integral of our function, we've got our determined limits here, do our calculation, and yes, we get a positive 2. And so that's going to be area 2, which is equal to 2. And then so we want to sum up both of our areas, and we do, and we get 4. So the total is 4 square units. Now remember, to save a lot of time, we just really need to do, for example, 0 to 2, get our answer, and then just multiply by 2. It will just be a whole lot easier.